Hello everyone and welcome back to another video. So today we're just going to be talking about the authentication attacks and just plain simple deauthentication attacks and just cracking PCAP files or cracking the passwords within the PCAP files. So just very easy today. We're just going to go over two tools. Just because this video would just be short, just using one tool. And I did do this before in my previous video with Wireshark. So this is just its separate video that I wanted to just add more to, just be more detailed. So yeah, in this video we're just going to be showing just two tools. It's going to be the Aircrack suite, and it's also going to be Wi-Fi as well. Sure, there are plenty other more tools, but these are just kind of the basic ones that I would recommend kind of anyone getting into this field or this type of offensive security to start with. It would be just Wi-Fi signals and just kind of learning the basics of Wi-Fi. So without further ado, let's just get straight into what we need. So once you've opened the terminal, first off you're gonna have to check if you can put your network interface card or your network interface card into monitor mode. So I'm not exactly sure how you can check. There are some ways you can check. I'm pretty sure you can find a script online if you to check if your network card can actually support monitor mode. And what monitor mode is basically allows you to change the mode of your network interface card and actually be able to see packets and send packets as well. Not necessarily see packets, but send packets and deauthentication attacks. It's very complicated. I don't know the exact whole thing. I just know that you need monitor mode for this to send deauthentication attacks, and yeah. So once you figured out if your network interface card can actually support monitor mode, there's an easy command that you can do that actually comes with the Aircrack suite, and I believe it is sudo airmon ng, and then first you want to check kill, which what that does is it checks for any conflicting processes, which would be anything from WP supplicant to network manager, and it just completely kills them. And the reason why that's important is because sometimes network manager or WP supplicant can interfere and just pull your card back into manage mode, and it'll just ruin your experience and make it a lot more difficult. So basically that's what that will do, is airmon-ng check kill, and then it'll kill these processes. And then what you can do next, it has been a while since I've done this, so I'm not exactly sure what the command, but I think it's let me check the man pages. So you can always just check the man pages. Script is enter wireless cards into monitor mode. Yeah, so all you have to do is just do the argument the script airmon-ng with the argument start, and then your interface. And there are a lot more stuff you can do, which I didn't know you could already put into a specific channel. If you already know, and the frequency, if you have a card that supports, I guess 2.4 and 5 gigahertz. There's also the stop, after you want to stop it and use your stuff as well, your internet, if you want to stop the monitor, because once you're in monitor mode you can't really connect to your can't connect to your wireless access point and then access the internet. So here's the one we already used. This is check kill, and this is the verbose debug, and I'm pretty sure there's a bunch of other options you could do with this. So all we're really interested in is the start, and then the stop. We're ready to check kill. That's the first thing you need to do. So we're gonna do sudo airmon -ng. Did I spell? No, I didn't spell that right. Start and the name of your interface, which should be something along the lines of LAN, or it should just be the interface with the most information. So yes, it's got to be a wireless. By the way, it's got to be a wireless network interface card. Because ETH0 won't work because it can't send and receive wireless packets and wireless information. So that's just I just wanted to get that out there. So sudo airmon g and then start, and then the name of your interface, and that should have it started. It should put it into modern mode as well. And then what you can also do, if you don't want to run the airmon ng, I have a specific script that is just regular. Oh, right. Because once you start the script, it modifies the name of your interface card to LAN0mon. So if you want to stop it, you have to airmon-ng. I keep saying airmon. Stop LAN0. LAN0mon. Okay, and then iwconfig again to check the status, and then it should be in manage mode. And these don't come back up by themselves, so you're gonna have to restart those, once you're done with everything. But just the just so I can show my scripts, they're pretty basic. They're just kind of bash scripts. There is this one to turn your interface card back up, and from monitor to managed, and it's just bin bash sudo ifconfig LAN0 down, so that puts your wireless card down, so you can make changes on it. Then it changes its mode to managed, then it puts it back up, turns it back on, and then it restarts the network manager and WP supplicant. And just to execute, all you have to do is just bash or sudo bash, depending on privileges you have. And it basically does, we already have it up, but we just wanted to do that to start the WP supplicant and the network manager. And slowly but surely it'll turn on. Yeah, see, it should be on. And now the other script that I have is the network off, which it just turns it into modern mode. So it does bin bash sudo server network manager stop, and so WP supplicant stop, and then turns it off, puts it into modern mode, and then just turns it up. So I'm pretty sure airmon g has like the same thing going on, except for it just changes the name of your interface. So yeah, let's actually get into some pen testing. So we have it on, right? So let's just put it into modern mode, and let's actually get started. So there are two ways to actually, if our main goal is to capture the ePOL packets, the handshake. So let me just actually start from the beginning. So what we're after is the handshake, and the handshake is done on a network every time someone successfully connects, which means inputting the PSK or the password. And it's a lot more complex, but all you need to know is that when you successfully log in, you do a four-way handshake with the router or wireless access point. And this handshake is visible to anyone who's listening on the network already, who's already connected, or who's not already connected. Sorry, who's just listening in on the radio, on the Wi-Fi radio, I guess, if you want to call it that. And to anyone who's listening on the Wi-Fi radio, these packets, these EAPOL packets, or EAPOL packets, are being sent just like in unencrypted and just in thin air, and you can just capture them and obviously store them and then crack them. So so I'm gonna show you the whole process behind the scene on the wire as well, just so you can get like a better understanding of everything that's going on. So let's just confirm again that we are in monitor mode, and this is a 2.4 gigahertz card, so it's only going to have 2.4 gigahertz availability, so we're only going to be able to scan 2.4 gigahertz networks. So if you have a 5 gigahertz network that you want to try this on, you're going to have to buy a 5 gigahertz network interface card if you don't already have one. So our first step is going to be checking or looking for our wireless access point that we want to pen test. So again, let me just preface this by saying this is for educational purposes, if I didn't say that already. This is for educational purposes. Don't use this on anyone's on any wireless access point or any connection that you any router or don't use this on any wireless access point that you don't have authorization to do. So like I said, only for educational purposes, so don't use this for anything bad. And also another thing that I wanted to say is the only way this attack actually works, like I said before, is when you get the handshake. So by getting the handshake, someone needs to be already on the network, right? Because that's how you get the handshake, is when someone enters a password or someone just connects. It doesn't necessarily have to be someone enters the password. Is someone, for example, leaves the proximity or the range of a access point. If someone leaves that access point, their phone or whatever disconnects, and when they come back into the range of the access point, it reconnects, and that also counts as a handshake as well. And that's kind of exactly what we're trying to do. Is we're trying to forcefully disconnect a client from the network so that we can recapture the handshake. Because what you could do is you could passively look for the handshake, which is non-intrusive, and all you have to do is just sit on the wire and patiently monitor or just patiently wait for the handshake to be exchanged. And that's non-intrusive again, like I said. You can't really detect that. And that's kind of like the safest way, but again, that takes a long time. Hypothetically, if you were trying to do this on your network, right, and you didn't want to forcefully kick someone off the network, you would wait for that, and it might take like a day or something. Like someone, for example, they're at work, right, and they've disconnected from the access point, and when they come back at like 5 p.m. or 6 p.m., they reconnect, and then you would have to wait up until that 5 or 6 p.m. to get that handshake capture, and then attempt to decrypt that. That's a later story. So that's one way you can do it. That is the passive mode, which doesn't require you sending the authentication request and kicking clients off, which will easily be traced back to you. So that's one thing. So that is the passive mode. The active mode, or the red teaming mode, or the aggressive mode, if you will, is like I said. sending the authentication packets through, I think it's MDK3, I believe, or another method that there's like different methods, but deauthentication, and then there's a different packet, but I don't remember exactly the name. And all you're basically trying to do is kick people off, like I said before, kick people off so that they can reconnect, and then when they reconnect, you have that handshake. And that probably takes maybe like 10 to 15 minutes at the most, and that is the fastest method of gaining. I mean, we're going to be doing both methods here, but that is the fastest method in theory of getting the handshake, at the cost of being visible and being detected, and then being just seen, because you're basically sending it from your MAC address, I believe. So yeah. So yes, I've explained a lot, but yeah. So all you need to know is that you need a client already connected for this specific attack to work. So again, let's get into it and stop dilly-dallying. So all you need to do is we're going to be using. So we're in modern mode. So we're going to be using we're going to be using AeroDump, which is a tool that lets you see all the access points in your range, and it shows you a bunch of very helpful information. And let me actually do that. AeroDump. As you can see, I've already done this before. However, I specified a channel and output and everything, which we will be doing as well. So all you have to do is sudo aerodump-ng and -i. What basically -i does is specify the interface that you want to use. So if you have multiple interfaces, right here is where you would specify which specific one you want to use. So we want to use LAN 0, or if you used the first script, which was which one was it? Yeah, Airman ng. If you use the Airman ng script, it would be LAN 0 mon, or if you use my script, which I will leave in the description, it's just going to be LAN 0. So all you have to do is sudo aerodump-ng-i for interface and LAN 0. And you should already be seeing all the access points, just all the access points in your area. And I will be going through each of these just so everyone can understand. The BSSID is basically the MAC address, I believe, of the router, of the access point that's sending out beacons and that's sending out a bunch of information. Sorry. And then the power, I believe, let me check again just so I can know exactly. Yeah, the lower the power, the closer it is to you physically. So if you have a 35 or 38, that is the closest one to us. It's because it's in the same room. And we also have 49s, we also have 60s, 67s, I think I saw 80 here, I'm not sure exactly. But yeah, it depends because it's the physical location, it's the physical power that access point is sending out. So obviously the lower the number, the closer it is to you because it has more power, more signal. It's kind of like looking at your phone and looking at the signal bars and seeing like if you're in the train underground, you're obviously gonna have a lower signal, so you're gonna have like 1 to 2 bars because you don't have access. You're not that like close away. You're not that close to the tower, right? And if you're outside, let's say in a big city, you would have full bars because you'd be closest to that tower. So it's on the same principle here. So we have done this, right? And then let me also explain beacons. Beacons is the number of beacons. So I'm not exactly 100% sure, but access points send out beacons. They're basically like, hey, I'm here, and it's basically just that on repeat. And different routers, don't call me on this, but different routers send different amount of beacons, as you can see here. So some send it more frequently, some send it more rarely. but they do still send beacons, and that's how your phone or your laptop can connect, is through the beacons, because it knows an access point is there, is because the access point is basically yelling. It's like, hey, I'm here, hey, I'm here, hey, I'm here. Basically, that's an oversimplified version, but that's kind of what is happening here. So data is the amount, I think, of data being sent. That's kind of obvious, I believe, but I think that, or might be, no, yeah, I think that is the amount of data. I'm not exactly sure on this column. And the numbers, hashtag or numbers, I don't know exactly this one as well. The channel, however, is very important. That is the channel, that is the channel the access point is currently on. So you might be asking yourself, why are there different channels? Why aren't they on the same channel? Well, the simple answer to that is congestion. If multiple, as you can see here, 11 is pretty congested. If multiple access points are on the same channel, all of that, well, basically it's just going to be congested, it's going to be slow, and it's basically like trying to fit like more cars on a single. It's like if a bunch of cars were on one side of the road instead of using the other roads. I guess the other open roads, it's just all the cars are just using one road instead of using all the other roads, I guess, if you kind of want to use that analogy. So there are channels, I believe. I don't exactly know all the channels, but I believe it goes from 1 to 11, maybe 12. Don't quote me on that. Do your own research first. But yeah, it does go from 1 to 11, and you can, in the router settings, you can adjust what channel you want to be on. So obviously just don't select any of these. These are just kind of the generic or the default channels that they've come with, or that they scanned and seen probably. I don't know exactly how it works, but I think some do scan and maybe automatically pick the channels, or some are just like defaulted as that. So why the channel is important, like I said before, is because you're going to want to know the channel of the ESSI, the channel of the network that you want to pen test. And for us, that's going to be Netgear. So we're going to be interested in channel 11. That's basically just honing in on the network. And then the MB, the megabytes, is basically saying the maximum allotted, or the maximum amount of megabytes or megabits, basically the amount of bandwidth that access point supports. So here it would be 130, 260, 195. This is a printer, so it doesn't really need to be, it doesn't need to have that much, that much bandwidth. But most of these are access points, and yeah, some of these are 540, which yeah, so it kind of depends, I guess, on the plan that you get. So if you get like a 500 megabit plan, you're going to need probably more than that, a router that can actually handle that amount of bandwidth. So yeah, and the WA2 basically means the encryption style or the encryption type, which is WA2. There's also WPA, and then there's also open, and there's also WPA3 now, more recently. But yeah, as you can see, some of these are WPA3. I think it's pretty rare though, but some are WPA3 encrypted. But ours is WPA2, thankfully, because I think the tool only accepts WPA2, WPA, and WPA2. And let's actually keep going. And PSK, PSK I think is just the pre-shared key, and that's just the passcode or the password that you input into the access point to let you access the internet. I'm not exactly sure about MGT or SAE, but yeah, we move. So here's the ESSID. I'm not sure about the exact name of it, like you can search it up on the internet, on Google, and find out what ESSID stands for and BSSID stands for. But what you need to know is that ESSID is the name of the network that you're interested in, as you could probably see. And then the BSSID is the MAC address, and the MAC address is like the physical address of the device. So, sorry. So the BSSID is like the physical MAC address of the device. The ESSID you can change, but the BSSID you can never change, because it's burned into the I think it's the PCB or something along those lines. So yeah, that the BSSID is unchangeable, so that's always going to be the same. But the ESSID you can change. You can go into the router settings and change it. And yeah. So the one we're interested in is Netgear. So we're just going to stop the script with Control C, and we're just going to highlight Netgear to make sure all the information we have is accurate. So we're going to open a new terminal with Control Shift T, and this is just the preliminary scan to actually find the access point. Now we're going to be honing in on the access point. So we're going to be using the same exact tool, so don't worry. So it's going to be sudo aerodump -ng, and here's where the channel name comes in. So we're going to look at the channel name, not the channel name, sorry, the channel that the access point is using. So it's going to be 11. So just type that in, -c flag for channel 11, and -w because we want to actually save this capture and then crack it in the future, or in like whatever, you know what I mean, crack it in the future. So we want to save it, so that -w is to write it to a path that you want to write it to. You can do home/user/ whatever, right? Or you could just do it in the same directory that you're in right now. So we'll do that just for the sake of it, and we will just type a name for it. This is going to be example, and our interface again, so don't forget that, and just replace this with your interface. So the command is basically will be the same for you, except for the interface. Like I said before, just use your interface. And again, a simple way to find that out is iwconfig, and it should be the one with the most information on it, or the one in modern mode. Sorry, that's a better way. The one in modern mode is the one that you should be using. So right, so let's actually use the ESSID, because we didn't specify the ESSID, so that was my fault. But before the channel name, you do /BSSID and make sure you are on the correct one. So that is our MAC address. Okay, and just Control Shift V, paste that in, and channel 11, output to example, and interface -I LAN 0, and let's hit enter, put in the password. BSSID, yes, that is correct. So for the --BSSID, you need 2 dashes, and this is the honing in part that I was talking about. This is obviously, we don't have any clients connected to it because it's just an empty access point, but we will connect the client in right now, and this is where I'm going to show you the passive way that you can do it. So you can just kind of leave the script running, and it'll collect the PCAP. It'll collect the PCAP when it detects the handshake. And let's actually just connect right now, just to show you how it is without the... Let's actually open Wireshark at the same time so you can see everything behind the scenes. So I'm just going to connect my device to this network. Okay, and this is basically, I don't know if I can show this, but this is basically everything that you can't see. I guess that's kind of a bad way of putting this, but it's basically what routers do, or what access points do. Access points broadcast their SSID kind of like every second or every other second or something like that, so devices know that they exist, because if they weren't broadcasting their ESSID, you wouldn't have a clue if the access point was even up, if it even existed, and you wouldn't be able to access it. But there's an exception with the SSID broadcast disabled, and I think the only way you can access that is by maybe Ethernet. I don't know, because you can disable SSID broadcasting and still access. It's like hiding something. I forgot exactly the terminology. But there are some exceptions to that rule. But basically, as you can see, well, let's just stop it so I can actually show you an example. You can see, like right here, it's a broadcast. Everything here is a broadcast, and that is a broadcast, right? It's broadcasting its name, and it's from a source, and it's just broadcasting it out into the open world so anybody can hear it. And that's basically what every... This is just for one access point. So that is basically what every access point is doing. And if you would be able to actually see these packets like in air, it would be so crowded. But yeah, this is basically what is going on when you put your or this is basically what the access points do behind the scenes. This is what you don't see. These are the frequencies that you don't get to see with your naked eyes. So yeah, this is basically what everything does. Every access point broadcasts their ESSID, so you can contact them, so you know they're there, right? Let's see. There's also a bunch of other stuff that I'm not exactly sure on. Yeah, like probe frames, beacon frames, and stuff like that, and QoS data and stuff like that. But we're not interested in that. Let's start a new capture and apply a display filter of EAPOL. So we're only interested in handshakes. Now, obviously we're only interested in our network, but if someone does happen to connect at the same time that we're doing this, it's going to show their handshake as well. So this is what Wireshark will see. Wireshark kind of sees everything. I'm not sure if there's a specific way you can filter it down, but there probably is. But I just want to show you what it is on the line that happens, because in the script it doesn't really show much. So let's go ahead and enter and log in to the access point. Okay, just log in. And right there, as you can see, it's still sending messages, which is very weird. This is just half the message. I might be putting a wrong yeah, I might be putting a wrong password. Let me just change that password again. But basically what you're seeing right now is the first half. It is the first half of the interaction. So it's going to be the first message. It's out of 4. Like I said, it's 4 packets sent. That completes the whole handshake. But basically we've only gotten the first and the second message because we didn't successfully authenticate. We just kind of partially authenticated. We didn't like send the full password. And now now we did actually successfully connect. So you should see the one of or 1 of 4, 2 of 4. There's no 3 of 4, but there is a 4 of 4. So maybe this would be unsuccessful. We'll still try it, but this is basically what you should see: is the 1 of 4, 2 of 4, 3 of 4, and 4 of 4. And this is basically what the script that is the error dump captures. And obviously, as you can see, WP handshake captured for this MAC address. And over here, it'll show you everything from 130 megabytes. So it'll basically show you everything that it showed you at error dump, the original one, but it's just filtered down. It's just narrowed for our specific access point. So we have our client connected, and we didn't do anything. We didn't kick them off. We didn't do anything aggressive. We just stood and waited for the handshake. So I believe this is ours, right? This isn't anyone else's. Okay. So let's go ahead and stop the Wireshark. Okay. And let's also stop the script. Okay, so if you did happen to put this in a file, or it's just on your home directory, just open it up, or just see that it's there first, verify that it's there. And it usually should, sometimes, I don't know exactly the exact command, but sometimes it saves to a PCAP, sometimes it saves to an IVS. I don't know the exact extension name for this, I just know it's IVS. And so we've captured it basically, right? We're just naming down the steps. We've put our car into monitor mode, we've done the preliminary error dump, then we've done the narrowed down error dump, and then next step is to actually crack it. And you might ask, how do you crack it? Well, this is the interesting part, right? So you don't actually brute force it. I mean, you could, but brute forcing is it's very heavy. Like it takes a lot of your resources. If you actually want to brute force it from, for example, if the password is alphanumeric, which means both letters, both lowercase letters and uppercase letters, and numbers, and we're not even talking about symbols. We're just talking about numbers, lowercase letters, and uppercase letters. That would take kind of an eternity, I think. Just the sheer possible combinations is insane. And the only way you could really brute force that is either with like a quantum or a supercomputer, and we don't have any of those. So what we're going to do to circumvent that is use a list. And the list is actually pretty, the backstory, like I said, if you watch my other videos, the list is actually has a really cool backstory. It is from a, no, I forgot where this was put. I forgot exactly where it was, but you could just do locate RockU. But the story is that the company, I think it was called RockU or something, I forgot the exact name of the company, but the company was basically breached. I think it was basically breached and had all its passwords kept in plain text. And these are all basically the most common, because it was a big company, right? So these are kind of all the common passwords that were used, and sometimes are still used for some logins. Rarely though, because most of these passwords are like six in length, and most websites won't even let you create a password that is less than 8 and has symbols and numbers and uppercase, just to reduce the chance, or the ability, or the chance to get brute forced. So let's just cat that out. It's in user share. I was looking at a completely different directory. So sec lists, should be just been word lists. Sec list, no, user share, sorry, word list, and then it should be RockU. However, if you just newly installed it and don't have it extracted, RockU is actually in a zipped format, which is just rocku.text.gz or gzip at the end. So all you have to really do is just run. I will show you actually in a different window. All you have to do is just sudo gzip-u or sudo unzip. No, it's gzip. I think it's dash d or maybe dash u. Just check the man page. Oh, spelled that wrong. And gzip dash d for decompress. So just write sudo gzip dash d and then rocku dot text dot gz, and all that'll do is just decompress it, and it'll give you the just plain text text file. So yeah, just keep that in mind if you don't have that already unzipped. So let's just, this is probably a bad idea, but I was gonna cat that out, but let's actually less, and you can see it just move down. Like some of these are obscene words, but just bear with me. Just we're just gonna move down the list, and you can see it's fairly long. Yeah, it kind of doesn't end. It's pretty long, but it does have some are longer than 6. Some are just numbers. Some are, you won't really get away with using these in our time. Like some of these are Harry Potter, and although they are rare, some yeah, let me see that they are pretty rare, but they are still used in some of our like Wi-Fi passwords, because you don't want to remember like a whole thing for Wi-Fi passwords, right? So most likely what you will do is probably just put in a password that you can remember, or if you like really well, yeah, well, basically what you will do is just put a password that you remember, and that compromises your security due to like attacks like this, which is very easy to do. It's kind of just there are scripts for this, so it's very just easy to pull off by some 12-year-old kid, right? So what my message is just if your default password is just numbers, change that. Right, if your default password is numbers, letters, uppercase, and all that, that's fine. You could leave it. If it's like 8 to 10 characters, that's fine. But don't change your password to like anything simple, or that would be easily guessed. And if you want to see if your password is in this file, you can just grep it, which basically you can just do, for example, Rockstar, and then the path. And obviously, as you can see, there's a bunch of words, a bunch of passwords with the name Rockstar in it. So there's 0 Rockstar, there's point Rockstar, there's Rockstar, there's like Rockstar by itself. There's Rockstar Girl, Rockstar Punk, Rockstar. There's probably just even Rockstar by itself. So it's see, even by itself. So it's a very common password, and like I said, if you want to check it, go to the RockU text and just grab it out, see if your password is in there. Yes, I mean I think there are like other password checkers, more recent, since the Rockstar is a pretty old and deprecated, not really deprecated, but it's a pretty old list, and not that many people use it. But just to say that you're not allowed to use it doesn't mean that it doesn't happen. So some people still have like these lists, these passwords as passwords. So where were we, right? We have the IVS file, so now it's time to crack it with our text file. So basically the way this works is that the password that we have in here I think we can. Well, we'll see. We'll see during the cracking phase. But you can usually open this up and see the exact EPOL and handshake files. But yeah. So basically, the password is hashed. This is like the simplest explanation. The password is hashed. By hash basically means it's a one-way conversion to like a so basically how do I put this? It's basically like a one-way conversion from plain text to just cipher, if I should call it cipher, to ciphertext, which it's basically unreadable. It's just random words and numbers, and uh, and each letter in our alphabet has a specific hash, right? And that hash, or each word has a different hash. Like, I don't know how I can show this, but let's actually try to do a I don't know exactly how to describe it, but for every letter there's a hash, like I said, and for every word there's a different hash. And just changing that word with, for example, a letter will result in a completely different hash. So for example, for the letter the, or for the letter, not for the letter the, for the word the, sorry, for the word the, you would have a hash like this or something. There would be symbols and stuff, but probably symbols. I don't know if they have symbols, but it would be a hash like this for just the word the, right? And then if you have, for example, if you change or added a letter or subtracted a letter, right, it would be a completely different hash, right? But the thing is, um, it's it's not the same hash, but in a way, like, the hashes are repeatable. So this is kind of what that bases it off on. So if we were to find out how to find out this password, like let's say your task was find out this password, how would you do it? You would reverse that process. Um, you want to reverse the hashing. You would also hash a word, right, and guess it. So you would hash. Let's say you have like three options, right? Let's say the word that we're trying to find out is the, right? And we're given three options. We're given the, apple, and cherry, or whatever. And we hash we turn the into a hash, and or we turn apple into a hash, we turn cherry into a hash, and whichever one matches, like physically matches, the hash that we already have is that word. So it basically matches those hashes, and that's how it figures out what the password is. So all it's doing is just turning every word in that file that I showed you in the Rocky file. It's turning that into a hash, which then gets matched with our pre-existing hash, which is in the example -0-ivs file. And every word being turned into a hash, being matched, turned into a hash, being matched, and it does the same thing for all the words in that list until it finds it or it doesn't find it. Because like I said, this isn't a guaranteed way, it's just a way of guessing. It's kind of like, so dictionary attacks are kind of like just trying different passwords. Like if you ever forgotten your password, say Facebook, right? You've most likely kind of done a small dictionary attack on yourself, right? So you've probably tried password. Let's say, for example, you've tried password 1, password 2, password 3, password 4, password or your birthday, or some other passwords that you have in your memory, right? And that is kind of an example of a dictionary attack. So you're basically sitting there. It's kind of the automated version, the automated version of sitting at the keyboard and typing all these passwords that you might have used. So that is a way of describing that. So let's actually get into the cracking, and yeah. So sudo, because we're going to need sudo privileges for this, and we're just going to do aircrack-ng, and the name of our file, which is whatever you named it. If you named it example, it might be this. And then it's also, let me actually see exactly what we need, right? So once you specify the name of the file, you just do the -w for word list, and you find where you put your word list. If you're using the same word list as RockU, it will just be in the user share word list. Word list? Yeah, word list. And then it should just be RockU. If you're using a different word list that you downloaded previously, just put that path for that word list, and it would basically work with any plain text word list, as long as all the words are just like on top of each other. Just yeah, one word per line, basically. That is the format. If you're also, if you want to make a word list, you could use Crunch. So this is also the format that you should use if you want to make the Crunch is more used for brute forcing, but you could also kind of use it as a dictionary. Like if you already have a word in mind, like let's say the Wi-Fi has the word cheese in it, right? You know it has the word cheese. Like that's guaranteed, is that it has the word cheese, but you don't know the other numbers or the other letters or the other symbols. So what you can do is just make sure it says cheese, like that's the first 4 lines, that is cheese, and then the other ones are just going to be symbols and passwords, and then you can just use that as a small dictionary. So just as an example here, we're just going to modify this. We're just going to do I'll explain everything, but basically this is just an example command, and it uses the tool Crunch, which basically generates a brute force. This is more for a brute force, but you could do sort of dictionary in a way, but it's mostly brute force. So what we're doing here is we're using Crunch, and we're generating a minimum of 3 numbers and a maximum of 3 numbers from 0 to 9, and then we're outputting it to a text called brute, or whatever you want to name it, right? And you could use that, I guess, if you know that the specific wireless access point is, for example, TP-Link. All TP-Link routers have just numbers. Like that's their default password that it comes with, is just numbers. So you could easily just create a brute force list, and then you could just try every single number. Obviously make it a little bit easier for yourself and start with like 6 or 8 or whatever the minimum is, and don't start with 3 or 0. Right? So you could do that with like a TP-Link one if you already know how it's vulnerable to like weak passwords, because all TP-Links usually are. They start with like a minimum of 6, maybe a maximum of 8 or 10, and they just have numbers, and you could probably do that in like a day. Brute force that, depending on speed of your device you're using. So this is just something I wanted to show that you could do. I'll show kind of like a sample without actually outputting it, and it'll just generate us all this information. Like I said, it's just basically brute forcing. So this is also sometimes used depending on your scenario. So let's actually get into the meat and start cracking. So, like I said, sudo aircrack-ng, name of our file, and the word list, which is the -w flag. And we have a pretty simple. That's what I've been trying to say, is that we have a pretty simple password that I've set up for my access point. So this might be even finished in like a couple seconds. So let's just click enter and see. Obviously put in the password, and in like 2 seconds it was found. In like literally 2 seconds it was found. The password is Rockstar, and now what we can do is just grab the password, obviously turn off everything, and put your wireless interface card back into manage mode, turn everything on, and then you could connect to the internet, or connect to the access point with the password, right? And then this is a lot more more information here, but it's basically the master key, transient key, and then the equal HMAC, which has to do with something in here. There's like a specific HMAC. It's a little bit more complicated to explain, and yeah, I don't even know like the exactly everything that's going on here as well. I just know like the important parts. So this is the only reason we found it is because it was in the dictionary. Again, if you try this on your router, your wireless access point, and your password that you chose is not in the dictionary, it's just gonna go blank. It's gonna go through all of it. Might take like 3 hours or whatever. It's gonna go through the whole list, and if it doesn't find it, it's just gonna say key not found. So again, yeah. And this is just the simple way that we found it. This is the passive way. So everything is basically the same for the aggressive way, except that in the aggressive way we actually kick people off. So let's actually get started on that. So let's go ahead and clear. Let's go ahead and remove this. So let's go ahead and remove that file. Right. And we're going to be doing the exact same thing. We're just going to be... Do we even have that? Yeah, we have the MAC address. So sudo arrow dump dash ng dash BSSID. BSSID, paste that. Then dash C for channel, which is the same channel, hasn't changed. And dash W to output it into a file. I'm just going to call this example 2. And then specify the interface. And that should be about it. This works. Maybe we forgot something though. Okay. So we should be connected, and we should see our maybe our device isn't connected. Yeah, there we go. So this is this lowercase part. If you didn't already know, this lowercase part basically shows you every single device that is connected to the access point. So, like I said, this attack does need someone to be on the access point, someone to be connected already. And the aggressive mode is basically just going to be kicking them off, so that we can actually be there and see the handshake when they reconnect. So this is basically just simulating them leaving and coming back. So that's basically what it's going to be simulating. But it's just going to be kicking them off with the authentication packets, so that they don't have access. It's the deauthentication, I believe, it's something that the router also sends. If it tries to deauthenticate you for some reason, I don't know the specific reason that it tries, but deauthentication is sent, rarely, yes, but is sent sometimes naturally by the router or access point. So this is the device that we have connected to the wireless access point. And you can see frames, rate, and power. And this is all we need is the BSSID. The station is, or do we need a station? No. Alright. The BSSID is the BSSID of our wireless access point. So we're going to be using this information, which is the station, which is the MAC address of the device. So we can go ahead and open a new terminal. Let's close that. So in this terminal, we're just going to be using the AirPlay script, which is, I think, also part of the Aircrack suite, or the Air suite, however you want to call it. So this one is a little bit long, I believe. What was it again? AirPlay. Okay, good thing we have our old script. So -0. So the script is called AirPlay NG. So run that with sudo privileges, right? And the -0, we're gonna do a -0, not 0. And the dash 0 basically means that this is going to be, it signifies that this is going to be a deauthentication attack. And then space 0, right? So dash 0 for the just to let it know it's a deauthentication attack. Then 0, which basically stands for infinite. Basically, we're not going to stop sending deauthentication attacks. And then dash A. This is kind of like the best way you want to actually use this script is with the dash A and the dash C. So the dash A is the MAC address of the so the dash A is the MAC address of the wireless access point. So it's going to be this. Right. Let's actually stop that for a second so we can copy this. Right. Just for the sake of this. Is it dash A? Yeah, I think so. Right. Yeah, I believe so. I haven't used it in a while, so it's a little bit rusty. The dash A should signify the wireless access point, and then the dash C should be the client. So, which would be the client, which would be the station, or the underneath the station. This should be the client. So go ahead and grab that. Alright, and then all that's left to do is specify your interface. And here is the fun part. So we're going to actually let me just close this. And we're going to be sending the deauthentication tags, and we're going to look exactly how it or we're going to see exactly how it looks like in the air. And also don't forget to have this the arrow dump running in the background. We closed it before just so we can copy and paste, because it doesn't let you copy and paste while it's active. So make sure this is active is very important. And going to continue without saving. That's for Wireshark, by the way. And then we're just going to send the no replay interface specified without the dash I flag. So let's actually get Wireshark up and running, and let's start the attack. And you should see almost immediately a deauthentication. If you could pause, you'll see it. Deauthentication. And it's basically deauthenticating our device right here. It's kicking it off. And you'll see it'll take a little bit. It takes a little while, so to warm up and actually clog. So that's basically what it's doing. It's just clogging, sending so many deauthentication packets that's going to clog this and disconnect it enough so that it reconnects. So I'm monitoring it right now. It's still doing well. Still connected. Sometimes, depending on what access point you have, it might block the requests, might not let them come in. But as you can see, it's kind of a flood of a deauthentication. We can just pause this right here, and you will see deauthentication. I'm pretty sure this is acknowledgement. So it's from the source, which is us, I believe, or 92. No, it's forging it, which is very interesting. It's forging it to be from this source, which is the access point, and it's telling this device to deauthenticate, and it's talking back to it, or someone is talking back to it and saying it's acknowledgement. It might just be like an empty acknowledgement, and then the device is talking back to it, and then the device itself is trying to deauthenticate the destination, or its talking to it, sending it the authentication packet, and then this is talking back to it, the authentication, empty acknowledgement, the authentication. I don't know why the device is trying to send the authentication back to the router, but it does. So I'm gonna set this as a filter, and we're going to start that up again. We should be seeing the authentication, authentication. And it does take some time. Sometimes it doesn't work, sometimes it does work. This is usually the best way that it works, is when you specify the access point and the device. That it's usually when it's recommended actually by the makers of the script. So it's not really doing much. It's still pretty good. It might take a little while. I'm just gonna let it run. It might just be that the actual wireless access point, or the router, again, whatever you want to call it, the wireless access point is probably just blocking or dropping the authentication packets. That also might be a possibility. I discussed in my other video about this. So we can see a bunch of deauthentication attacks, but nothing's really happening on our side. That's because we are specifying exactly where it needs to go. And if it's probably blocking it, it might not let it through to the device. So another thing we can try is, because it's been 12 minutes already, so another thing we can go ahead and try is just to deauthenticate it like a broadcast, so without a specific device. Which usually this is supposed to work. Maybe we need to wait a little bit more time, but I'll try the other way, which is just to just without the client. So I believe it should just be --bssid -a -b, I believe, without the double dash -a. Okay, so just -a, and this should be broadcast now. Just sending a straight broadcast. Straight broadcast without the sending it to a client. Is just broadcasting it. And what's super weird about it and cool about it is that it actually forges the from part. Because if you look at the source, it's the same MAC address, has the MAC address of the access point. So that's really cool that you can do that. It's just forge the authentication packets from the actual access point. Which obviously, yeah, you can do. You can forge packets, you can forge ARP, you can forge ping, you can forge a bunch of other stuff. But it's just cool to see on the wire. That's all. We'll run this for a little bit, and we'll see exactly how long it takes. So we've been doing it for quite a while now, and it's still not deauthenticating any or just deauthenticating at all. So we're just gonna cut it off, and we'll just show you what would have happened, which would be just the because usually it does work. That's why I'm a little bit surprised that it didn't work now. So we're just gonna disconnect it manually and reconnect again to show what would have happened. Right? It would have just reconnected, disconnected from the deauthentication attack, and reconnected. And that's what would have happened. So, yeah. So now we'll just do the same thing that we did, like I said. So now we have example 2-02. Oops. Forgot to stop sending the deauth code, or the deauth attack. So once we already have what would have been a successful deauthentication attack, we would just find a file and do the exact same thing that we did if it's in this terminal, which is the sudo aircrack dash ng, what is it? Crack dash ng. And it's basically the same thing as you did last time, just change the name of the file. And example sudo aircrack sudo because you need sudo privileges, aircraft dash ng, the name of the file, dash w for word list, and find the actual word list that you need. Put the path in, and enter your password, and that should be the key found. So, yeah, I don't know why I changed the keys for some reason, but this was the previous key. So that's basically it. That's what would have happened if you actually did the deauthentication attack. Don't know why that didn't work. I am hotspotting, but even with the hotspot, the authentication works sometimes. So it's just a little spotty with the script and everything. So yeah, I hope you enjoyed the video. I know I said I was gonna have another script for this video, but it's been over an hour. This video is like over an hour, so I'm gonna have to cut some parts out and stuff. But yeah, the next video will be Wi-Fi, the Wi-Fi script, which is basically this script. Oh, sorry. You can specify a bunch of stuff. You can specify the WPS, which is more vulnerable access points, and they're vulnerable to the WPS attack, which can be done with like the pixie dust and the reaver and a bunch of other tools as well. So yeah, this is just like the exact thing we did right now. Like the thing we did right now is like the manual version. Everything here is just automated, like completely automated. Like you don't have to capture anything. It'll even if it is WPS, it'll do its own reaver and pixie dust attacks. And if it's not susceptible to WPS attacks, it'll do the same either PMKID capture or the four-way handshake that we just did right now. So yeah, this tool is actually fully automated, and it's like super easy. So the next video, it's probably gonna be shorter than this, because this video was kind of like everything, like, not exactly everything, but most of the things you need to know for Wi-Fi and for Wi-Fi penetration testing. So yeah, let me just say the disclaimer again. This is only for your own network. That you only should use this for educational purposes. And yeah, thank you for watching the video, and have a great rest of your day.